Thank you. All right. It is September 20th. Less than 2 weeks until the end of this quarter.
Really?
Really. Yeah, 2 weeks from today, you guys will be on fall break. Yeehaw!
Yeah, that's not what I'm talking about.
Me?
No.
Okay. All right, ladies and gentlemen, solve each formula for the indicated variable. You have a few of these. These are, I would say, quite complicated. And don't be surprised in your homework. There are some that have rather unusual letters. You'll see some in your homework. I think there'll be one you've got a that sort of symbol and a that sort of symbol. Greek. Yeah, those are Greek. Yeah,
so negative.
Yeah.
So, like, really kind of chemistry, I was like, why are we talking about oxygen in negative form?
Does this say F4?
Where four, A sub 1. 4. Oh, that's funny. I wonder why there's a weird space. Yeah, interesting. No, it's 4. Yeah. Okay. Yeah, these are just Greek letters. And these are lowercase Greek letters. And just imagine this is a U, and that looks like a R. Okay? Just pretend they're letters you know. Okay. Don't worry about it. All right, these formulas are both rather complicated looking. This notation, we would describe this the way we would say it is A sub 1, as in subscript 1. Okay. This would be R to the n minus A sub 1. And it's just, we're trying to isolate A sub 1, meaning getting it by itself. And these formulas have to do with arithmetic and geometric series, which I'm not sure if we'll actually talk about this year. We might not have time. But believe me, that's okay. You'll see them in Calc 2. Yeah. So here we go. We want to isolate A sub 1, and there's a lot of different things that we could do. They're both up here in a numerator. Can I get rid of this denominator?
Yeah.
What can I do?
Multiply by
Yeah, can I just multiply it to the other side? Okay. So S sub n times R minus 1 equals A sub 1, R to the n minus A sub 1. All right, so you can certainly multiply your denominator to the other side. That is just fine. Okay. Now, this is an interesting thing. I have a couple of A sub 1s. And I'm trying to get it all by itself. It's kind of interesting. I think this is quite challenging. Did you leave your phone? Is it 39 or? Yeah, I didn't. All right. GCF, greatest common factor. There are two terms here. What do they have in common?
A sub 1.
Yeah, so I'm going to factor out the A sub 1. That is very, very tricky. What's left behind if I take out A sub 1? R to the n minus 1. Very good. How do you know you did that right? Rainbow. Yeah, distribute it. And A sub 1 times R to the n is there. And then A sub 1 times 1 would be that A sub 1. Okay, so we know we did that right. Okay. Now you'll notice the A sub 1, I only have one of them. That's good. I'm trying to get it by itself. This is A sub 1 times this entire group. How do I get the A sub 1 by itself? Divide by the entire group. Crazy. This is incredibly complicated, ladies and gentlemen. And if you understand that, then that's remarkable. A sub 1 is equal to S sub n quantity R minus 1 over R to the n minus 1. And this is a lovely answer. The GCF was really
Is the SN an actual variable?
S sub
Just
n.
like a placeholder?
It's S stands for sum, so it's the sum of the first n terms, and then
I didn't know if it
arithmetic.
was, like,
Go
a
geometric.
placeholder, like, F of X or something like that. So I thought it was a placeholder. So
Oh, gotcha.
So we need to.
Yeah, I need it. Yeah. Bless you. Okay. B is actually a little bit better. All right, again. S sub n stands for the sum of the first n terms. These are formulas. This one, this is the formula. Have you heard of the story of Baby Gauss?
No, please no.
Do you want to hear a story?
Yeah.
Oh, so Baby Gauss was not really a baby. He was like 5, but baby-ish. Okay, and his name was Carl Friedrich Gauss. Okay, and he was rather precocious in his one-room schoolhouse, and his teacher could never keep him busy. And so one day he was done, and he was, causing what 5-year-old boys do when they're bored. And his teacher was like, Carl, you sit down and you add up all the numbers between 1 and 100 at 5. And yeah, so 1 plus 2 plus 3, all the way to 100. And he came back, and he sets to this task, and he's like, wow, this is kind of an interesting thing. And so he sits down, and about 2 minutes later goes to his teacher, I know the answer. It's 50-50. And she's like, no, that's not, can't possibly be right. And he says, it is, it's 50-50. And so she sits down, and she has to, go through this and figure this all out. And so Carl Friedrich Gauss then explains, look, it's a pattern. When you look at the first term and the last term, they add to be 101. And then when you look at the second term and the second to last term, they add to be 101. And when you look at the third and the third to last, they add to be 101. Well, how many of those 101s do you have? 50. So 101 times 50 is 50-50. That's this formula. Okay?
Wow. I love that kid. How old is he now?
He'd be dead. All right. So kind of an interesting story, and this is the kind of math that I think is fun when you just get to sit down and figure out patterns. I had to take a whole class on just patterns in college, where we figure out all of these kinds of formulas just given here. This is this. How do you figure it out? If it was not just 1 to 100, what if it was 1 to 1,000 or 1 to 5,000 or 1 to 1 million? All right, what's the sum? And so it's kind of an interesting thing, but that's what this formula gives you the answer for. But it's really just thinking about patterns. Okay. We want to try and isolate A sub 1. That was a 3-minute digression, I think. All right. And so we're trying to move away everything around it to get it by itself. What do you want to do first? Times by 2. Very good. So we have 2 times S sub n equals n times the quantity A sub 1 plus A sub n. Divide by n is a great suggestion. I heard distribute the n. You absolutely could do that. It's a little less efficient. Okay, so we can divide the n. Now, this is S sub n. It's not S times n. It's a different thing, so you can't reduce those, just so you're clear. S sub n. Divided by n equals A sub 1 plus A sub n. And then how do you get A sub 1 by itself? Subtract A sub n. Yeah, 2 times S sub n over n. And we're going to subtract A sub n. And that's that. These are, I think, more complicated than those that you'll see in your work today. So,
Yeah, that's.
yes. How would you what?
Get rid of a sub.
If you had like S sub n divided by S sub n, that you could reduce.
What exactly is the subscript numbers?
Well, these subscripts like S sub n, this stands for the sum of n terms. So here, this would be the sum of 100 terms. The sum of the first 1,000 terms. So this is just, n is the number of terms in our series of numbers.
Oh, so this is
Yeah.
all.
Yeah, it's just all interesting stuff. Here we go. This is up to you if you want to write down the word problems. But I would summarize. So let's write down the important parts. Set up an equation and solve. So here, at a career school, the ratio of physical therapy students to nursing students is 2 to 11. So here's the important part. It's 2 what kind of students? Physical therapy students to 11 what kind of students? Nursing students. Those things are always in order. They what is that called? Respectively. They're in respective orders when they present that. So this is the ratio of physical therapy students to nursing. This would be the physical therapy. The 11 would be nursing. Nursing students. And it says if there's a total of 260 students, 260 students total, enrolled in the 2 programs, find the number of nursing students. What are we trying to find? Okay. So we want to find the number of nursing students, which means I'm going to let, should we use that? Can I use n? Can I let n equal what? The number of nursing students. I think it's important whenever you can, and this is what we're trying to find. That's the unknown. That's why it's our variable. But whenever you can, I think it's important to use a variable that has meaning to it instead of generic old x. Okay, n for nursing makes sense, right? Number of nursing students. Okay, so this is a ratio. Ratio is also known as a fraction. So if I know that I have a fraction of 2 physical therapy students to 11 nursing students, then I should also be able to compare the actual number of students. So what do I know about our students? So 11 goes with nursing, right? And that's what we're trying to find in, yeah? So in nursing students is to the 11, okay? And then how would we figure out the physical therapy students? Oh, you're really on the right track, I think. Let me point out that there's 260 students total. 260 minus n. Very, very good. Let me do this logically for you. If there are 10 nursing students, and we know that there are 260 students total, how many are physical therapy students? How'd you get 250? You subtracted 10 from 260, so you did 260 minus 10. All right. So we have n nursing students. How should we figure out how many physical therapy students there are? 260 minus n. Do you see how that works? Sometimes just putting in a number makes things so much more clear. This would give us the number of physical therapy students. 260 minus n. Do you know how to solve that? What should we do? Cross multiply. Okay. So we can cross multiply. So I would have 2n equals 11 times 260. 2,860. You guys are good. Minus 11 in. And so I'm going to add the 11 in. That's going to give me 13 ins equals 2860. And it turns out that the number of nursing students is 220 nursing.
Where you can do percentages instead of
Probably.
so do it.
And in general, there's always another way to do it.
Yeah, so just do 11 divided by 13 and multiply that by 360.
Yeah, that's what
I don't know if that will do this.
I just divided it into 6 by 13.
Because there's 13 parts in total. There's the 13. Yeah. So that, yeah, absolutely more than one way to do stuff. Yeah. All right. So it's much shorter. Tasha bought a dress at a 60% discount sale, which I thought was weird wording, but you know. 60% discount sale for $132. What was the original price of the dress? Okay, what are we trying to find? Okay, so since we want to find the original price, we're going to let P equal what? The original price of the dress. Let P equal the original price of the, I wouldn't want to use O. No, because it's confusing with the 0. Original price of the dress. So there's, again, multiple ways to do this. And this is certainly one you could just probably calculate it out. But I'm going to do it the way the book shows me how to do it. So what I'm thinking about is we have a original price, which, and then we have we're discounting, so that'd be subtracting, right? Subtracting our discount. And this is going to equal the sale price. So our original price minus our discount is going to give us what we paid, all right? The original price, well, is 100% times whatever that original price happened to be. What is 100%? It's just 1, right? It's just 1p, yeah. Minus, what was our discount? 60, yeah, it was 60% of what? That original price. Yeah, it was 60% of the original price, and that's what we get to discount our cost by. And then we ended up paying $132. Well, 100p minus, well, 100% p minus 60% p is 40% of the price. This is what we end up paying, and maybe you jumped right to that. Does that make sense to you? If it's a 60% off sale, we pay 40% of the price. Okay, so maybe you jumped right there. That's what I do. But either way, you worked it. Okay. The other thing we want to make sure is we don't calculate in percentages. What do I have to do with percentages? Change it to a decimal. What is 40% as decimal? 0.4. Did you know that percent is literal? Per means divide, and cent. How many cents? 100. 100 pennies in a dollar. 100 cents. And so 40% is literal. 40 divided by 100 is 0.40 or 0.4. Okay. Anyone ever talked about that before?
Yeah.
She paid 60.
Yeah, that's why it's weird wording.
Okay.
Yeah, so the wording in this book, they'll use this wording, and this is how they mean it. Yeah, I thought it was a little bit weird as well.
It's like if something is 60%.
Yeah, so 132 divided by 0.4. Yeah, I did find the wording a little bit weird. What's the original price of the dress? $330. Yes. Dress was originally $330. Okay. All right. And again, ladies and gentlemen, I would encourage you to read example 12. Have a look at example 12 in your book real fast, and then start on the homework or classwork, rather. If you want you to not have homework.